Okay, hi everyone. Now I'm going to uh, further explain about design efficiency. Okay, for you to understand the purpose we do the design efficiency is to identify or to reveal the components or the parts from our design that potentially can be eliminated without the loss of functionality. Okay, we don't just eliminate, we do the integration or combination with other parts. Okay, and this is the equation. This is the equation. As you can see here, the A components, the number of A components divided by the total number of components. So what is an A component? Okay, we have A and the other one is B. Okay, what are these? A is actually the critical or essential components. Okay, essential, and this one is not non-critical or non-essential lah. Okay, non-essential. And okay, how do we identify our parts falls into the essential or non-essential categories? Okay, let me explain you by using this example. Okay, let's see the first one, the original design. I have counted this. The total number of parts is 24. Sorry if I counted it mistakenly. Perhaps correct. Okay, so E is the A over total number of parts is 24. Okay, so how many essential parts we have here in the original design? Okay, let's say, okay, how to identify that? We use this chart. Okay, we use this chart. In this chart, if you see here, there are three stages of questions actually. 1, 2, 3 here. Okay, when let's say we take the base lah, this base. Okay, this base, and we try to answer these questions for the base. The first question, does this part move relative to all parts which have already been analyzed? Okay, actually the answer here is no. The answer here is, sorry. Okay, the answer here is no. Okay, the first one, the base. And is this part of a different material to all parts already analyzed? Actually, should this part made of different material compared to the other parts, especially the parts next to it? Okay, let's go back here. Okay, this one, and the part next to it is probably these two parts. This full part. Should the material be different? Let's say the answer is also no. Okay, and we go to the third question. Is this part separate to allow for its okay, what meant here is, should the part design be separated? Should this part be separated when later we want to do repair or maintenance or replacement? Okay, should this part be separated? Okay, looking back at the design, probably no. Okay, it depends on the design, the function, but let's say in this example the answer is no. So now we know that the B is, oh not the B, the base is, the base is B parts. Okay, let's take another example for the probably the bolts. Okay, probably the bolts. Okay, let's see for the bolts. Okay, the first question, does this part move? Okay, this is not moving, so the answer is no again. Okay, is this part of different material to all parts already analyzed? And I believe, okay, let's check here. Okay, this one, okay, this one, the part next to it is the washer here. Need to be different material? No. Okay, probably no. And is this part separate to allow? Should this one be separated lah? Um, okay, let's say yes lah. If okay, let's say yes. Let's say yes. And is the adjustment essential? Let's say yes. Must the part be separate to enable the process of replacement or repair or adjustment? Not necessary. Okay, let's probably lah. Okay, so the bolt also falls into B. The bolts also B. Okay, so we do this. Okay, let's take another example. This shaft. Okay, this shaft. Okay, we try to answer this question. Does this part move? Okay, it's moving, of course, because it's a shaft. Is the movement essential? Looks like essential lah. Okay, yes. And must the part be separate to provide the required movement? Of course, the answer is yes, because this is the only moving parts there. So now we know that the shaft falls into A categories. So this is A, this is A. Alright, so now from this example, okay, in the original design, E is probably because we didn't analyze here now I didn't analyze all the parts, but looks like only the shaft is essential. So 1/24. Okay, you understand it? It doesn't mean that only the shaft is essential, the rest is not essential. It doesn't mean that. What it means that the rest has a potential for integration or elimination. Of course, we need all this. Okay, all this group, we need this. However, the parts could be integrated with other components. Okay, so we calculate this and we get the design efficiency for the original design. Okay, then knowing this, which one is essential, which one is non-essential, so we discuss, we redesign, okay, in more detail. And after that process, let's say the team come out with the revised design, the one in the middle. So here is the total number of parts is 4. 1, 2, 3, 4. Okay, and we know that the shaft is essential, A, and we have 3 more. These 2 little covers and the main body. Okay, so let's try on the covers. So the first question, does this part move? Okay, the answer is no. Is this part of different material? Let's say no. It can be same. Okay, as compared to the two, the shaft and the main body. And is this part separate to allow for the Okay, let's say the answer is no. It depends on your design. You decide what are the answer. Let's say no, and the cover is identified as B component. Okay, this is A, this is B, this is B. Alright, so now we have the design efficiency for the revised design. Okay, so it's 25%, and we want to refine more because we have 3 non-essential parts over 4 total number of parts. Okay, I'll revise again the design, and the team come out with this. only 2. Okay, only 2. And alright, this one, of course, this become A. And yeah, you may try answer the questions for this main body. It should be A also lah. Okay, and here we have the design efficiency here. Okay, by having this lah. Okay, design for push and snap assembly. Alright, so you understand, yeah? So for your okay, and this in this example, the final design efficiency is 100%. Of course, it's not actually good. Okay, but in this example, I'm just showing one part, one small module of a small function of the whole design. Okay, but what you should calculate is for the whole, the design efficiency for the whole product, for the whole concept, for the whole idea, not only partially this trigger part, this holder part, not like that. So you calculate that for the whole part, and you repeat the process, okay, of identifying the design efficiency, modifying the design, and then compute again the design efficiency until you get the threshold of about 60% is good. Okay, 60 to 70 up to 80, not more than that. Alright, I think that's all. I hope you understand. Okay, if you don't understand, please ask. Okay, please ask. I welcome any questions from you guys. Okay, so that's all. Thank you and all the best. Bye bye.